Okay, good afternoon, folks. Get started so we can stay on track. Firstly, just welcome on behalf of AWS. Really appreciate everybody taking the time to come out and spend parts of your valuable day with us. My name is Andy Hindmarch. I'm the AWS Account Executive for Home Affairs, and it's with great pleasure that we've got Home Affairs here with us today for the first time to present a story around their customer journey with AWS. If I just reflect for a moment on the mission statement for Home Affairs, keep Australia safe. So it's a pretty broad remit, and we could spend the next half an hour just talking about the operational functions and value that Home Affairs brings to us as one of the super agency portfolios within Australian government. They're also an agency that, through the complexity of their business, has a complexity technology platform as well. So you're going to hear a little bit about how Home Affairs have gone about unpicking the monolith. Don't want to spoil their thunder around the story, but for me it's a really great example of how to build the guardrails in cloud, how to look at the foundations, how to get the security right, how to experiment, and then leverage from that experimentation, use the lessons learnt to go beyond into the next stages of iteration and imagination. So without further ado, it's my great pleasure to hand over to Matt Jones, who will be ably assisted by Paul and Chris for the rest of the presentation. Thanks, Matt.
Thanks very much, Andy. My name is Matt Jones. I'm the Assistant Secretary for Architecture and Innovation within Technology Division, effectively the Chief Architect for the department. So, as Andy said, Home Affairs is a very large and diverse and very complex organisation, and the business needs within the organisation are ever changing. The government can make policy decisions, legislation and regulation changes. We also have relationships with a range of national security agencies, both onshore and offshore. And we're also a member of the national intelligence community. So that creates a really dynamic environment, a very complex environment that we need to operate within. And the department has gone through a number of mergers and mogs over a period of time, and so consequently we've got most IT platforms that have ever been invented in the last 30 years exist in one form or another inside our organisation. The pace at which the business wants to run is often challenging for IT, but they expect IT to be ready, that we need to be agile. But on the other hand, IT is very complex and it's also very expensive. So in a number of areas of the business, ICT can't move fast enough. But in other areas, the business is actually very complex and we cannot change the IT systems due to legislative changes required in Parliament. But the business expects us to be ready to react to those changes when they are passed in Parliament. So we often do a lot of work in preparation for things going through Parliament, and they may or may not get there, but the business expects us to be ready, so we need to be very agile. The department has over 450 business systems that are considered essential to the functioning of the agency, and then there's probably a long tail of maybe another 600 or 700 IT systems that have grown up over time that fulfil a specific need for one or more areas of the business. Most of these systems have relationships with one another, and so managing the ripple effect of making one change in one system and managing that through into another is actually very, very complex. So this slide illustrates a lot of the moving parts with the formation of the portfolio of Home Affairs in late 2017. ACIC, AUSTRAC, ASIO, the AFP and the ABF came into the fold. We are considering whole of portfolio solutions within that space, and so that's a very different dynamic where no longer are we looking purely internally, we're also looking to leverage capability in some of these other organisations. So this is obviously a very, very complex place to work, and if you've worked at the ATO or DHS or Defence, it's probably not unfamiliar to you. So our challenge is to break down this environment into digestible pieces, sort of eating the elephant, if you like. So today, Chris, Paul and I are going to talk a little bit more about how we actually plan to do that, but I'll just provide a little bit more context to what Andy alluded to before. So Home Affairs has around 16,000 staff working in 62 locations across the globe. We have about 2,000 IT staff and contractors. We have contracts with major service providers, fulfilling very important pieces of capability for the organisation. But we're very much in the volume business, lots of people and lots of cargo. Last year we facilitated the movement of around 190,000 permanent migrants into Australia. There were about 8 million Australians travelled overseas, going out and coming back in. We had more than 8 million visitors come to Australia, Most of them leave, most of them don't overstay their visa. And there's about 2.2 million temporary residents that are managed by the department on an annual basis. So that volume creates complexity. It's just really, really complicated environment to work within. On the cargo side, we inspected over 54 million mail items at the border, processed 51 million cargo consignments, detected 42,000 packages of illegal drugs at the border with a combined weight of over 11 tonnes. And in addition, the department is the second largest revenue collector for the government. We collected about $20 billion last year in cargo related charges and excise, and about $3 billion in visa application charges. So the challenge that we've had is how to take this large monolithic beast that's grown up over the last 30 years and break it down into a number of much smaller agile chunks, effectively trying to convert an elephant into a gazelle, which is very challenging. For those of you that work in government, you know that the cycle that you go through to actually secure funds, to actually commence a project starts long before the project actually kicks off. In large organisations like in our area, you might need to go to 15 or 20 different teams, different committees to actually get agreement that this is what you're actually going to do. You then drop into a project delivery cycle. You then go through traditional test, build, deploy, iterate backwards and forwards and through that. And then, of course, you've got all of your testing cycles and cab changes to run through. It's not untypical for a release inside the department to touch at least 8 or 10 different platforms for a typical visa change. And that happens fairly regularly as the politicians or the parliament pass legislation and change the rules around visa processing. So the challenge is that we need to make the environment much more agile so that we can react to what the business wants, and that's what the team's been working upon. So we've been working on ways to break down the complexity. So even though the organisation is large and cumbersome, we can treat each component much more discreetly, and it actually makes the environment much more interconnected. So at this point, I'd like to introduce Paul and Chris, and they'll go into some of the detail.
Good afternoon. I'm Paul Morrison. I was a developer for about 10 years before moving into architecture, and I was tech team lead. And then I switched to project and program management about 12 years ago. I've been a program manager at the Department of Home Affairs for about 8.5 years now, and I've worked on many large programs, both software and infrastructure programs.
Hi, I'm Chris Gough. I'm a software architect and developer at large with Gosource, a Canberra-based consultancy that primarily services government agencies. In particular, I do a lot of work with cloud adoption, emerging technologies, and delivery modernisation.
So following on from what Matt said, our department, like I'm sure your department, is large and complex. And don't for 1 minute think that what we're saying is that we can somehow magically get rid of this complexity. No, what we're thinking about is how we work within this same complexity, but by breaking that complexity down into more manageable pieces. So each piece needs to act in a similar way, become less custom, and more patterned or predictable, like our gazelles. For example, we in ICT don't plan at all to simplify the visa legislation. Every media report that creates a new headline about the latest visa loophole that some nefarious body has exploited, for us, this creates new visa rules, new legislation, more software, and multiplies the myriad of different test cases that we have to run each release. No, business is complex. We have to accept and deal with that. So what is it exactly that's slowing us down? After running many years of 6 monthly releases, all interconnected through an enterprise service bus, we think we know why our change is difficult and slow. Our business areas, like everyone else's business areas, are very pressed for resources and has a full-time day job, so planning for future change can be problematic. Secondly, we went down the big ESB path, and that requires projects to choreograph several teams in unison to ensure the ESB custom request and responses always work between the different systems. And we have ageing systems, and they weren't originally wrapped in coded test cases like behaviour-driven development tests, so we have a large number of manual testers. Even a simple code change can require running huge manual regression test suites, which always pushes us back into waterfall. And we have to run projects before the legislation passes. With recent governments having such slim majorities, at times the legislation doesn't pass. But we've already run the project and coded up all the changes, because if the legislation does pass, it has to be live a couple of weeks later. So we have to hurriedly unpick the code for that project a few weeks before go live, and that can leave us with pockets of technical debt. And each system is a monolith, so there's a high fixed overhead cost for even small incremental changes. One of the reasons the Enterprise Service Bus isn't working for us is because we find we get very little reuse from the services we put on it. Furthermore, our funding models are tied to project work rather than an outside-in view of how we should best design and expose services. So we have over 300 separate services, and we're only seeing about 10% of reuse with any one service. The depiction on the screen shows how the ESB creates a landscape where integrating systems becomes custom code. System A has to send a different request packet to the 3 different systems, and they in turn respond with 3 distinct response packets. Individually, each custom request response only represents a very small coupling of the systems, but added up over time, you create an ecosystem of quite tight coupling. Not the reuse we were all hoping for when we embarked on this paradigm 15 years ago. So we've been thinking about whether there is a way to simplify our integration landscape so that systems A, B, C and D can avoid needing specific interchange contracts with each other and instead implement a new pattern. So I hope this sets the scene for what our problem is, and I'll hand over to Chris to start to describe where this has led our thinking.
So complexity is not inherently bad, but there is good and bad complexity. Complex things can always improve over time. Good complexity is resilient, it's adaptive, and it has a kind of emerging intelligence. Bad complexity is fragile, inflexible, and has emergent risks. As an outside observer coming into Home Affairs, the key problems, as I saw them, were 1, it's too difficult to respond to user insight because change is too slow. Half-yearly release cycles plus significant planning lag times. 2, small changes are difficult to make cost-effectively. Communication and coordination overheads across many vertical silos imposes a high fixed cost on any change. The efficient unit of work is too large. This leads to some principles that are independent of technology, decoupling and automation. The image on the left illustrates the current complex web of interconnected monoliths tied together with an ESB. The illustration on the right shows an idealised integration surface that would allow the same business domains to operate more autonomously. It's more of a loosely coupled network of comparatively simpler services that only communicate through their defined interfaces. This reduces the communication and coordination costs. We express this as API microservices, but in reality, it's about refactoring architecture and governance. This isn't possible without enabling technology, effective automation.
If we could reliably do on-prem DevOps, then we would. But it's not as easy as just installing Jenkins and stocking up on sticky notes. My infrastructure teams are extremely capable and they work really, really hard. But as a single IT department, the playing field's not level. We haven't given them billions of dollars to invest in on-premise ICT automation like the cloud providers have. So we don't have a suite of self-service infrastructure patterns that we can deploy with a quick turnaround. We don't have a suite of infrastructure that's highly programmable with management APIs that my team can script and automate as software-defined networking or infrastructure as code. We don't have effectively unlimited hardware, so sometimes my project suddenly gets bogged down in some data centre work that I wasn't expecting, and we have to complete that before we progress. And for the legacy systems, we don't have coded test cases for every application to ensure that we haven't regressed something after we make a small change. Instead, for each new project, my architects fill in spreadsheets, paperwork, log requests through our service management systems, and then chase and follow up. Sometimes the project infrastructure is delivered in a couple of weeks, and sometimes it takes a lot longer. There's not always a lot of predictability. And calling on new hardware and software often requires upfront capital budgets, licensing and vendor contracts. So often it's a budget or licensing issue that suddenly stalls my project. In summary, I don't have an end-to-end pipeline of self-service, highly programmable IT automation that I can call on-premise.
This slide is about an end-to-end view of DevOps. Big bang change is too difficult and risky. The first thing we needed to do was to improve our ability to iterate. So we needed infrastructure as code, so that we can stand up and tear down whole environments on demand. I'm sure you've all heard the cattle not pigs analogy. Because of the instant availability, cloud was the easiest way for us to achieve infrastructure as code, so that's where we started. Then we needed continuous testing on every check-in, so that we can confirm our changes haven't introduced any regressions. This meant that our new version is always a candidate for production. So we're using CI for build, test, and package, using contemporary open source tools. Then we needed some continuous deployment. We wanted releases to become as monotonous and repeatable as possible, rather than some choreographed dance across half the IT department. So we extended our CI to release management and production control, deploying lower environments continuously and using stage gates at higher environments. Some of these practices were already in place in different parts of the organisation, but we needed a full end-to-end pipeline from user insight to software release, from observation to response without bottlenecks. Anything that slows down our delivery loop is a problem. On screen is the AWS cloud pattern that we developed through a lengthy process with plenty of engagement with the security folks. It's a general purpose, high availability infrastructure pattern, and it's available to any new cloud project in the department. No matter what the project is, if they can start with this pattern, they can begin development in days, not weeks or months. You can see that it includes all of the basic network components like DNS, firewall, load balancer, queue service, and an API gateway. It has 2 subnets across 2 availability zones with an auto-scale group. There are some other optional components that we can add in, but I won't clutter the diagram. It's already pretty busy. It was a lot of hard work to get this pattern approved, developed, deployed live, and connected back into the department's systems with our first solution. But now that the bridge is built, other projects can quickly and simply reuse it. There's no spreadsheets required, very little ticket passing in a service management system. You can never suddenly run out of hardware. Vendor licensing and support is in place and all-inclusive. There are no project costs, really, until data starts flowing across the solution. Plus the whole network of infrastructure and platform services is scripted in code, so we can reuse it like any other code. We have a working DevOps pipeline to deploy application updates in the solution. This timeline shows some of the Home Affairs cloud adoption work. Our first project was the citizenship appointment solution in 2016. Then we built a prototype to see how we could traverse the tricky process of applying for a visa using a series of application programming interfaces rather than an ESB. After that, we built a number of other applications, some using Gosource teams, but others we supported the internal teams at Home Affairs. We earned a lot of useful knowledge about what works and what doesn't. Some of the things haven't progressed beyond the prototype or pilot stage, whereas others are thriving and keep growing, such as the appointment solution, which is now being used for many more appointment types beyond just citizenship appointments. This was the department's first cloud-native system. The original prototype was developed in partnership with the Digital Transformation Agency, who used their service design methodology to focus on user needs. The business problem here is that there's about 140,000 new citizenships conferred every year. As part of the process of becoming an Australian citizen, you need to sit an interview and pass a test. These tests are conducted in offices around the country by appointment. That's a lot of appointments. And they need to be scheduled at a time when both the applicant and the facility are available. The old system involved phoning a help desk, waiting on hold for up to 45 minutes, and then having a Home Affairs staff member update your appointment for you, which is expensive and not something most people find convenient. What we have now is a new system that provides a low-cost self-service model for applicants to change the time of their appointments online. It's significantly faster and more convenient than going through a call centre. By reducing the load on call centres, it reduces costs and also shortens the wait times for other kinds of queries. It's a public-facing system that integrates back into Home Affairs through the Enterprise Service Bus. The system security planning and approvals process took about 9 months, which is a lot longer than it took us to build it. The ability to deliver quickly is essential for productive experimentation. One place where the department likes to experiment is with improving the experience of travellers arriving to the country. The paper on the top left of the screen will be familiar to most of you. It's the inbound passenger card that you fill in when you arrive in the country. A team within Home Affairs created a pilot application for the inbound passenger card. This has not proceeded past pilot for a range of business-related issues that will be explored as part of ongoing business process improvement. This validated 2 important ideas. Cloud-enabled capability improvement. Unlike earlier projects delivered by Gosource, this time we provided DevOps support, but the product was entirely in-house. Second is the role of cloud in breaking new ground. This experiment was quicker and cheaper than it would have been using self-hosted systems, but the quality didn't suffer. A subsequent project was a capability to enable multiple countries in the Pacific to validate passports, record vessel movements in their territorial waters, and share information with each other. It used entirely cloud-hosted backends and was developed by an internal Home Affairs team, with Gosource providing DevOps again. This project received an Australian Border Force commendation. We mentioned earlier that reusing templates and patterns shortens the time it takes for a system security planning and approvals. Here's an example of a quick win that came off the back of earlier cloud engineering work. Overstaying your visa results in various costs and complexities that are best avoided. One way Home Affairs can minimise these problems is to make it easier to comply with visa conditions. The visa expiry notification system sends SMS messages to certain types of visa holders, reminding them of their upcoming visa expiry. There's 2 interesting things to note about this. It was very cheap to build and operate because AWS Platforms as a Service does all of the heavy lifting. And the planning and approvals went very quickly. Because we'd used all of those services before, it reused infrastructure as code from other projects. So far, everything I've talked about has been at the edge of the organisation. This is because of the initial posture with risk and keeping the initial experiments away from the main business systems. Because of these projects, the organisation has gained experience with doing DevOps and infrastructure as code securely. We've developed templates and patterns that satisfy the organisation's defensive security posture. We've made quite a lot of progress since the early days. While Home Affairs initially engaged Gosource to develop their first cloud-native solutions, they now have more than one internal team building and supporting cloud-native solutions using a mature delivery pipeline in a consistent way. This has taken a couple of years, and we now feel more confident to increase the scope of cloud adoption. Going forwards, the risk profile is different, it's lower. This is a helicopter view of Home Affairs business domains and resources in each domain. The boxes coloured grey are domains we haven't had time to do a detailed look into yet. So the resources in those boxes are our early best guesses. The boxes coloured blue, like citizenship and trade, are business domains we're working closely with and have modelled some of their initial resources. The yellow boxes are those resources we've prototyped in the cloud already. And the green boxes are those resources that are live systems in the cloud. They have a functioning microservice API, and some of them have user interfaces as well. This is the big picture of our integration challenge. It represents the internal integration surface. It's our herd of gazelles. This is the beginning of a process to envelop complex legacy mainframes with modern, developer-friendly APIs. It's a kind of roadmap for the first stage of decoupling the components of the elephant, so that we can refactor it into clusters of microservices inside autonomous domains. I'll summarise what I've said today like this. So far, we've talked about the challenge of scale, how slow releases and large units of work make it difficult to respond to insights. We've looked at how automation enables iteration, which leads to a healthier type of complexity, more robust and adaptive. We followed the journey from low-risk experiments at the edge of the organisation and how templates and patterns have been reused by internal teams. We also saw how established cloud patterns enables rapid delivery and experimentation. The next stage of the Home Affairs journey is to extend these practices and patterns deeper into the organisation.
So a lot of discussion in the application development space is now coming down to schedule, budgets and security requirements. We could try and build all new projects on-premise in a new microservices DevOps world, but instead we intend to aim for a hybrid where some services are on-premise and some are in the cloud. For resources with certain profiles, we can use the cloud to expedite the initial delivery and ongoing deployment. We can deploy the new service to the cloud with predictability in a matter of days, reusing our scripts. If we suddenly require another platform capability, we can plug in a new building block, many of which are already architected for high availability. When I have to deploy a new platform on-premise as highly available, I have to deploy 2 of them and spend 2 to 3 months testing that of high availability. And so there are some cost savings in using AWS's platforms since they share their costs over more than 1 million active customers and they employ a predominantly self-service automated model. So if we intend to move from our interconnected elephant to our herd of fast gazelles, we're going to need to do a few things differently. Redesign our monoliths over time to be much more granular applications. Remove the custom integrations between applications, and then let those applications self-service their integration needs via APIs. We need to wrap all of our new systems in comprehensive automated tests and use standard patterns to deploy applications into. We need to have a functioning continuous testing and continuous deployment pipeline. And we want to do lightweight prototyping with our business and then iterate quickly towards the intended solution, rather than asking or expecting them to detail all their requirements several months in advance. To achieve this, we will rely on the cloud, since we don't have this very high level of automation on-premise at low cost. If the overhead of creating and integrating a new gazelle is low, then we will have moved a long way towards addressing some of our initial problems. Thank you for your time today, and I hope this presentation has provided an overview of our journey so far.